That faint smudge near Cassiopeia isn't harmless, it's inbound. Andromeda is on a collision course with the Milky Way. The payoff is simple, and it lands right now. It will rewrite our night sky within a few billion years. A galactic collision sounds explosive, yet space is mostly empty distance. So stars rarely hit, but gravity sculpts everything we see. Imagine tidal bridges stretching across the sky like rivers of diamonds. Dark lanes of dust will lace the horizon, bright as moonlight. Constellations we learned will warp, drift, and finally dissolve into streams. Our sun won't notice a direct impact, but its neighborhood changes. New starbirth will ignite in colliding gas, painting pink nebula arcs. Two supermassive black holes will dance, then merge, releasing deep cosmic ripples. You can actually see Andromeda tonight from a dark site. It spans about 3 degrees, wider than the full moon. That little blur is a future panorama, already heading our way. There's a number that sets the stage, 2.5 million light-years. That is Andromeda's current distance, closing at about 110 kilometers per second. Run the clock forward, and gravity does the patient steering. In roughly 4 billion years, our galaxies brush for the first time. The disks pass through, and enormous tidal tails unspool from both sides. Between close approaches, they swing apart, slowed by stolen orbital momentum. Gas clouds ram into gas clouds, compressing, igniting rounds of starbirth. Star formation can jump to tens of suns per year. As the cores approach, each galaxy grows stretched and off-axis. Distant observers would watch 2 spirals twist like pulling taffy. From Earth, the sky widens with structure even before contact. Today, Andromeda spans about 3 degrees, already 6 moons across. In 2 billion years, it grows dramatically, over 20 degrees wide. At first pass, its arms and hours stretch nearly horizon to horizon. The second pass drags long bridges, stitched with newborn clusters. Dynamical friction bleeds energy, and the cores sink together. Within 6 billion years, the main bodies settle into one. The shape becomes a big lentil, with a warm central glow. Astronomers nickname it Milkomeda, a new home for both heritages. The sky then calms, and the tidal streamers slowly fade. But globular clusters will keep orbiting wide, like bees around amber. Their arcs will trace the merger's memory for billions more years. Through it all, the solar system drifts quietly within the mix. What would you actually see standing under that future sky? Start at twilight on a cool October evening after rain. A pale ellipse rises where Andromeda sits tonight, but brighter. You notice mottled texture, not a simple blur or patch. Dark dust lanes cut across the glow, like ink on glass. Over 10 million years, it grows by a noticeable fraction. Human timescales are tiny, yet telescopes stack the change. In 2 billion years, the oval spans 20 to 30 degrees. The Milky Way band crosses it, weaving a luminous cross. Then the first brush comes, and the sky erupts with structure. One arm stretches overhead like a highway, dotted with bright hydrogen regions. The other arm curls low, behind a jag of mountains. Weeks and seasons still pass, with planets tracing their paths. But the background canvas has depth, braided and alive. During the second swing, 2 bright cores share the sky. Their halos overlap, and star clouds sketch a luminous bridge. Nights near new moon become astonishing, almost as bright as dusk. Deep shadows still exist, yet the horizon holds silver texture. If you time-lapse centuries, tidal tails swing like scythes. Star nurseries flare pink, then cool, then give way to blue. The constellations get shredded, and local asterisms lose coherence. You would relearn the sky because the map has changed. After merger, the band returns thicker, like a sandbar. It glows warm, with subtle dust rifts etched across it. Farther out, globular clusters sparkle like frost on branches. Each arc traces orbits and whispers how the dance ended. Close your eyes and picture the highway of stars overhead tonight. Open them and feel how small worries shrink under that canvas. Here's the unsettling twist: almost no stars will actually collide. Space is mostly distance, far more distance than stuff. Picture the sun as a grape in a soccer stadium. The nearest star would be another grape, dozens of stadiums away. Gravity still matters because orbits get tugged and traded. Our sun could migrate outward or inward by tens of thousands of light years. Encounters with passing stars will reshape comet reservoirs like Oort clouds. Most planets stay bound because the scale difference is huge. The dramatic fireworks come from gas, slamming into other gas. When clouds interpenetrate, they shock, cool, and compress efficiently. Dense knots collapse, birthing clusters and brilliant blue giants. Some regions may light up like the antennae galaxies nearby. Those systems form stars at several tens of suns per year. Our merger could push similar rates for short, lively bursts. Supernovae follow, enriching gas with metals and dust for planets. New star clusters could hang low in our future evenings. Their light may rival the Milky Way band for weeks. Collisions between stars remain vanishingly rare, even during wildest passages. Gas does the showy part, while stars mostly redirect silently. That difference is why mergers look messy, yet remain surprisingly gentle. Starbirth makes chaos glow, and then winds blow the embers. Over time, those regions fade, leaving clusters and calm halos. The young giants die quickly, but their metals seed tomorrow. Bottom line, it will look ferocious, while mostly rearranging orbits. Deep in each core, a heavyweight anchors the surrounding stars. Our galaxy shelters Sagittarius A star, about 4 million suns. Andromeda hosts a larger giant, near 100 million suns. They will not collide immediately because distances remain enormous. First, stars and gas drag them inward through dynamical friction. Over time, they form a binary, orbiting within a dense crowd. Each close pass flings neighbors outward, stealing orbital energy efficiently. Gravitational waves then take over as the pair tightens. Their whispers sit in millihertz, perfect for a space interferometer. Lisa could hear a similar system halfway across the universe. Our event lies far ahead, yet the physics is universal. If gas feeds the nuclei, a quasar phase may flare. Jets could light intergalactic space, powered by black hole spin. For us, the danger stays minimal, given the huge scales. Any flash arrives as spectacle, not as a local hazard. The final plunge lasts minutes, but took eons to prepare. Waves ripple spacetime, carrying away several suns' worth of energy. Afterward, one heavier remnant sits calm, ringed by settled stars. The core relaxes slowly, while outer streams keep memory. That quiet center anchors the final galaxy, steady and bright. Let's ground the story with a simple, clean set of numbers. Current distance, about 2.5 million light-years. Approach speed, roughly 110 kilometers per second. First close pass, around 4 billion years from now. Second pass, near 5 billion years with stronger tails. Coalescence, between 5 and 6 billion years after today. Final shape, a big lentil profile with a warm core. New name, colloquial Mulcometa, because astronomers love mashed names. Night sky brightness, higher during passes, then calming after settling. Solar system fate, migration likely, ejection unlikely but possible. Supermassive black holes, merger expected, with detectable waves in millihertz. You can hold those in mind while the visuals unfold. They aren't predictions carved in stone, but strong simulation consensus. The big picture stays the same, even as details wiggle. Those anchors make the timeline feel real, not just cinematic. New stars peak after passes, then slow as gas gets used. Globular swarms persist, orbiting high above the final disk. Tidal streams remain visible for eons as faint stitched arcs. That's the arc to watch if you love sky changes. So what happens to us down here on our small rock? The first truth is comforting: there is no fiery impact. Stellar collisions are vanishingly rare, as we already unpacked. Gravity still rearranges neighborhoods, especially during the wildest passes. Simulations suggest our sun could migrate outward significantly, over gigayears. A smaller slice of cases also send it inward modestly. Ejection seems unlikely, perhaps around a 1 in 10 chance. That would place us far into the halo, or beyond. If ejected, the night would dim but stay full of remnants. Planets mostly remain bound, despite gentle cumulative tugs from passing stars. Comet reservoirs will shuffle, sending occasional long-period visitors sunward. That could spice a few epochs with brighter comets and meteors. Human worries likely end sooner because the sun evolves onward. In about 5 billion years, it swells into a subgiant. Oceans may boil earlier, and Earth could become inhospitable. That schedule overlaps the merger, complicating any future vantage point. But civilizations could move outward, following cooler orbits around others. A colony under a red dwarf sky might watch safely. They would see the luminous bridges sweeping across their horizons. The grand display lasts millions of nights, punctuated by quiet. After coalescence, the sky softens and navigation charts stabilize. Our star would orbit the remnant calmly within a bigger home. The dark is never empty, even after colossal rearrangements. The new map would still invite hikes, questions, and wonder. Some nights change you because the sky refuses to ever look away. This is one of those nights, stretched across 1 million years. That smudge above Cassiopeia becomes a river and then home. Our night sky will change, and we already know why. Its gravity, quietly patient, yet endlessly creative with time. If that vision lit a spark, stay for the ride. I tell these cosmic stories often, with real numbers and scenes. Tap subscribe and watch the sky grow step by step. We will keep tracing futures calmly as the universe breathes. For now, step outside and find Andromeda's soft glow. Hold it in mind as tomorrow becomes a grander map.